Everyone, I'm Inokyu, and today, and welcome back to another video for the series. And today I brought a problem from KMO, which is the exam that I'm preparing for right now. So the problem is for an acute scalene triangle ABC, let D be the intersection of the side BC and the angle bisector of angle A. So we have an acute scalene triangle ABC. Okay. So we have uh okay. Uh is this okay? Yes, it looks like a scalene triangle ABC. You have A here, B here, and B here, and C here. And D is the intersection of BC and the angle bisector. So let angle bisector of A. So D here, and this is the angle bisector. Okay. Moreover, let E and F be the circumcenter of ABD and ADC respectively. So we have like E around here, and like I think F should be around here. Yeah. I think that's pretty legit. Yeah, I'm pretty satisfied. Okay, assuming that P not D is a point of intersection of triangle BDE and DCF, so you actually do need to connect them. Like this. Oh, okay. No, I don't like the drawing. I'll just draw it in the way that I usually draw. Okay. OXY be the circumcenter of ABC. So we have O somewhere. O somewhere here. Here is O. I guess around here is X, and around here, no, maybe here is Y. Oh wait, it's not F. Wait, what? What is F? I didn't draw P yet. Okay, so it's really hurt. No, so usually I draw better on paper, but I'm not sure like how to like draw them here. Ah, okay. Uh, yeah. Whoa, that doesn't look like a P. Anyways, I don't really care. So here is P. So prove that OP and XY are parallel. So believe it or not, these, why can't I, is, yeah. So believe it or not, these two segments, OP and XY, they are parallel. So we need to prove that they are parallel. And the way to prove that they are parallel is actually by, I really don't like the drawing, but there's no better way. No, well, my drawing is perfect. What is, okay. So what we're going to do here is we're going to extend like this. And oh, by the way, this is not my personal solution. This was uploading like, I don't attend the academy named EdCool, but I saw a solution that they posted in the internet and I really love them, so I really wanted to share it with everyone. Oh, this is so frustrating, but what can I do? Okay, so if you draw them, like extend the lines, there are a few things that we know, and the first thing is because the first thing that we know is that these two are equal to each other because E is the circumcenter, and yeah, they are equal to each other. And similarly, these two are also equal to each other because they are circumcenter. F is now because this is true, we know that if we let like this, I will just do it and then erase it. This angle plus this angle, these are the same. These are the same. Okay, now the angle right here and the angle right here, they're the same. Oh, so we know that these two are the same. And similarly, wait, actually, I think there's a better way. Instead of trying to prove it like that. I'm sorry, they were just two. Like O here. Wait, where's O? O should be here, and P should be somewhere here. So, yeah. I just make it bigger. Like Anyways, I need to draw this diagram again. So, like maybe here, like this. Okay. So we know that because here is like dots, it should be 2 dot here because E is the circumcenter, and 2 dot here. Meaning these angles are all the same. This one, this one, this one, and this one. That means this one and this one is the same. So this is also an equilateral triangle. Isosceles triangle, but they also share the other two angles with this triangle and this triangle, which means here should also be 2 dot. In other words, let here be A prime. A prime, B, C is cyclic. 왜냐면 because angle BA prime C equals angle BAC. Now what we're going to do here is okay, so first of all, we know that this is cyclic, and we're going to do something special, something really special, and that is actually extending our lines. But before doing that, let me quickly think. OX PXY. Yeah. There's actually a another parallelogram, but I think before explaining that, I think I need to continue like the other explanation. The drawing is so messy. So when we connect this, like X should lie on BO, Y should lie on OC. And I think that is quite self-evident. And let's try and draw these two lines too, like this. Now we know that. What should we try? Yeah. So actually, one thing that we can notice here is because P and D lies on this circle, like I will just say circle X. This is so what I mean by this is E, B, D, and P. It is cyclic, and similarly, P, D, C, and F is also cyclic. We can use that, and there is actually another one that we can try and use, and it is this one, OXD OXDY is a parallelogram, because, and let's prove why it is a parallelogram. So we just need to prove that these two are like parallel, and the reason is because, okay, let's say that this is dot, this is dot, and this is X, and this angle is X. Then we naturally know that this angle is 2x and this angle is 2 dot. Okay, so that's what we know. However, notice that O is also, so BOC is also a isosceles triangle, which means the angles that I'm indicating right now in red, they're all equal to each other. Here it should be 2 dot and 2 dot. So we proved that these two angles are the same. Now these two angle, this angle, it should be 180 minus 2 theta. 2 dot. This is also 180 minus 2 dot. So thus this is a parallelogram. So we proved it. We actually need to write them in the proof, but I'm quite lazy to write it right now. So if you connect this, therefore, let's just say that this point right here is M. We didn't use M here, right? Yeah. So therefore, OM equals MD. That's the first thing that we know. And actually, we can do another magic. That is, it is equal to MP. And the drawing is quite messy, but what was that? What did I just erase? What is? Yeah. So from this circle, the reason why they are equal to each other is because it's quite self-evident that these two are equal to each other, because it's a parallelogram and it's like this, the intersection of two diagonals. Now let's look at DP, this one, why they're equal to each other. So why these three are all equal to each other, and the reason is quite simple. It's just using congruency in triangle. Believe it or not, let's look at these two triangles. So just connect this, then because PD is a radical axis, it should be 90 degrees. That means 90 degrees, 90 degrees, and SAS congruence for this one and this one. So we have this one equals this one. Therefore, we know this. Meaning this implies that triangle ODP, this implies that triangle ODP is actually a right triangle. ODP is or angle OPD is 90 degrees. So we know that this is 90 degrees. But also notice that XY and PD is also a 90 degrees because like I'll write it. So PD and XY because PD is the radical axis of X and Y. Therefore, OP is parallel to XY. And that completes the proof. Yeah, so even though the drawing was, I would say, quite messy, I think there are a few takeaways from this problem. First is like drawing this extension. Second is noticing this using extension. Second is cyclic, quadrilateral. And third one is radical axis. Oh, I didn't know that we need to use radical axis. Radical axis. Yeah, and also fourth is basic properties. So if I was the one who was taking the test, like in this time, I'm pretty sure I will not be able to solve this problem because I contemplated this problem for I think like an hour, and the reason why I looked at the solutions because I kind of gave up, and I'm quite worried, but I hope this helped a lot for everyone who is studying math and me. So yes, thank you for watching this video, and tomorrow I'll come back with another fun problem. And thank you and see you tomorrow. Bye.